Hey guys, it's Off by One here, and today we're going to be solving threesome. In this problem, we're given an integer array nums, and they want us to return a set of numbers that add up to 0, but the restrictions are that the number cannot be the same, and they cannot contain duplicates. So for example, if we have this array, we can't just return two sets of zeros because that would be a duplicate. The brute force way to solve this is by having 3 for loops. So for example, this could be our I, this could be our J, and this could be our K. And we just move our K and J and I as we move along the array. And the code for that will look something like this. So here's a triple loop. I'm kind of assuming you know what this means already. So for I from 0 to the size of the array, and then J goes from I to the size of the array, and K goes from J to the size of the array. So for the second iteration, K would be moved up here, for example. And once we have that, we want to check if our sum is equal to 0, and if it is, we add that to the result array. But this has a few problems. The first problem is that it doesn't take care of duplicates. So for this example here, we can have this, and this in one of our result arrays, and then we can also have this, and this in one of our result arrays. And that would give us the same exact array, which is not what we want. So we could add a check over here to say, and if this set is not in our result. But now the other problem is that this algorithm runs in O of n cubed time, and that's not what we want. If the array was sorted, we could use a two-pointer approach to solve this problem in O of n squared time. So how can we do this? First, let's just simplify the problem so we don't even care about the triple sets. Let's say we only want 2 sets. So our nums array could look like this when it's sorted. And then now let's say we want to find the 2 integers that add up to 0. We can start at the left and then start from the right here. And then we can check if our left pointer plus our right pointer is equal to 0. And if it is, then we just want to add that to our set. And if it's not, then we want to move one of these pointers to the left or to the right one. So how do we check that? I've cleaned up the code a bit just so it's easier to read, and I've also changed the example so it helps us solve it. So what do we want to do if these two don't equal 0? Well, we can see that -2 plus 1 is equal to -1, which is less than 0. So what do we want to do here? We want to increase our left pointer by 1, so we can now point to this -1 here, because 1 plus -1 is 0. So I've written that code out now here. So if our sum is less than 0, we want to increment our left pointer by 1. Otherwise, we want to decrease our right pointer by 1, because that means this number is probably going to be smaller, and that'll get us closer to a sum of 0. So what we've done here now is condense these two loops into this while loop. So we've gone from a runtime of O of n squared for these two loops to a runtime of O of n log n. And the reason it's O of n log n is because it takes n log n time to sort, and it takes n time to go through this while loop. And that will simplify to just O of n log n. And while this pseudocode is still incomplete, I think it's enough to get us started for the coding portion of it. So let's get into the coding part. So to make this portion a little easier to follow, I'm going to just write the pseudocode out so we can build from there. So to start, what we want to do is initialize our result array to just empty, and then we want to sort our nums array, which in Python you just do it like that, and it takes O of n log n time and O of 1 space. And now I'm just going to write this while loop. So now that we have our while loop, we know that this is supposed to be inside of another for loop, so we can include our threesome. So the way to do that is for I in range of length of nums. So this would just go from 0 to the length of nums. We want to do this while loop. But what do we want to do before that? Well, before that, we want to check if our nums at I is equal to our nums at the previous point. And the reason we want to do that is because we don't want any duplicates. So If it starts with the same number as before, that means we're going to find the same pair, and we don't want that. Additionally, we also want to check if I is greater than 0, because we don't want to check that on the first point because we would get an out of bounds error. And if we do find a duplicate that meets this condition, we just want to continue to the next iteration. And then from here, we can just initialize our left and right pointers. So our left is going to be I plus 1, and our right is going to be the length of nums minus 1, so it's at the end of the array. And then now that we have our third number added here, we want to also have that included in our sum of nums. So we just want to do that. And we also want to add it to our results array. And we can just add it here at the beginning. And then now we're almost done. We only have one more thing to do. So when we actually have a sum of 0, what do we want to do? We can just increase our left pointer by 1. And we also have to check that this next left pointer is not a duplicate. And the way to do that is do a while loop. So while nums at left is equal to nums at the previous left, then what do we want to do? We want to iterate 1 forward. And also this has to be while left is greater than or less than the right pointer. And I just noticed that I didn't keep my naming consistent, so I'm just gonna fix that. And then now at the end of all this, we can just return our result array, because at this point we should have calculated all the possible pairs, or triplets I guess. So as you can see, the code is pretty efficient, and there are more checks you could do to maybe get this to run a little more efficient, but this works for now. So now I'm going to go through the code manually. So to start this problem, we're going to have to sort our nums array, which I've already done here. It's already sorted for us. And also I've initialized the initial pointers. So we're going to iterate through the whole array, and if nums at I is equal to the previous nums at I, then we're going to continue. But we can't do this one yet because we're still at the first iteration. So now we just initialize our pointers, which is already done over here. And let me just keep track of them here, just in case. So L is currently equal to 1, and R is currently equal to 4. So while left is less than right, we want to do the sum of nums. So nums at I, nums at left, and nums at right. So currently it's -4 plus -1 plus 2. And you can see that this is not equal to 0. This is actually equal to -3. So we go to these conditions. Since sum of nums is not equal to 0, we check if sum of nums is less than 0, which it is, and then we just increment our left pointer by 1. So now our left pointer is at the second index. And now we check again. Well, it's the same number, so we can just increase the pointer again. And we know that still is not equal to 0. So what we're going to do is increase the pointer again. And we can finally see that -4 plus 1 plus 2 is still not equal to 0. So what we're going to do is just go to the next I. So I've initialized the I to be at the second index, and then L and R are already initialized as well. So what we're going to do is first check if nums at I is equal to the previous nums. So then we're going to check, is -1 equal to -4? No. So we don't have to worry about this. And now we initialize our pointers, which is already done. And then now we do, if left is less than right, we'll do this while loop. So we check the sum of nums. Nums at I plus nums of left plus nums of right. So -1 plus -1 plus 2. Well, we can see that this is equal to 0. So what we're going to do now is go into this condition. So what we're going to do is add this to our result array. So our result array is now going to include -1, -1, and 2. And what we want to do after that is increase our left pointer by 1 to see if there's any other pairs. And now we check, is the nums that are current new left equal to the nums that are previous left? Because if it was, then that means we will be looking at the same pairs. And we can see that it's not for this scenario, so we don't have to worry about that. So now we can go to the next iteration. we check if the sum of nums is equal to 0. So for this example now, it's going to be -1 plus 0 plus 2. And we can see that this is going to be greater than 0. So we're going to decrement our right pointer. So now it's going to be here. And so now we're going to check if -1 plus 0 plus 1 is equal to 0, and we see that it is. So now what we're going to do is add it to our result array. So now our result array is going to include -1, 0, and 1. And so now we can just go to the next I, because we've reached a point where we can't continue our while loop. So now we're going to be at this index, and now we check. If nums at I is equal to the previous nums, and I is greater than 0, then we want to skip this current iteration. So let's see. -1 is equal to -1. So we do want to skip this iteration, because if we continue, we're just going to find the same pair of -1, 0, and 1 as one of our triplets. So now we just continue forward. And then now this is going to be our new I. So now we check if this I is equal to the previous I, which is not, so we don't care. We initialize our pointers to be here and here. And now we check. Do these three integers add up to 0? So 0, 1, and 2, well, they do not, because they equal 3, which is greater than 0. So what we're going to do is decrement our right pointer. So now it's going to be at the same place as left. And we can see that our while loop condition is no longer met, so we don't want to iterate anymore. So now we just return our result, which is going to be equal to this. And we know that's the answer because this was one of the examples given to us in the problem. If this video helped you in any way, please leave a like and subscribe. Thanks for watching, and I'll see you in the next video.